turn on your cameras. Insay. Murag karon po kita nimo. First time? Okay na. So kamu tanan na ka sulay. First time nimo? Okay, turn on your cameras please so that we can start our lecture. Okay, class, can you now read the board from your laptops or your cell phones or tablets? Can you clearly see the board now?
Yes, sir.
Okay na? Okay, so let's proceed. Okay, for this afternoon, we will be talking about keys. Now, if you recall, last time we were discussing about the three methods of designing shafts. No, you have the ASME code, you have the maximum shear stress theory, and you have the Mrs. Sinkis theory. Now, for this afternoon, I mean, the shaft is useless unless you attach something to it. No, usually it is most application of shafts are rotating, although there are stationary shafts. No? So shafts are circular in cross-section. It could be hollow, meaning na ibuslot sa tunga, or it could be solid. And most common are the solid shafts. Okay? Now, but the problem is, if it is shaft alone, what is it used for? No? It has to be a part of a machine. So, something has to be sent to the shaft. And most common are pulleys, no? Butangin mo pulley ang shaft. Gears. Butang mo ang gear attached to the gear. Attach the gear to the shaft. Pulleys. Flange couplings, no? And many private sprockets, no? Sprockets. They are also. Now, how do we, if we have these components and then we insert it on the shaft, then there should be a hollow portion on that component where the shaft is being inserted. Now, if you do not fasten these two, then probably the shaft will turn without the one that is being fastened turning, because it will just slide. So we have to place something, to insert something, so that whatever is being inserted into the shaft will also rotate with the shaft. Okay? Hubs are also common. In fact, hub lang gikon, no? Shafts and hub. General term for anything that is being inserted into the shaft is say, do you know of any term nga hub sa inyong kuan? Bisikleta. Oh. Kanang tauran sa radios, okay? And that is a hub, no? And then most common applications is kana siya insertan of shaft. Okay? Inserted on the shaft, and then the hub will rotate with the shaft. Or as the shaft rotate, it will drive the hub. Okay, so keys, the shaft and the hubs are usually, so hubs, or it could be gears, it could be pulley, it could be sprockets, no? Are usually fastened together by means of a key. So pahuutan na to aron inigtuyok sa imong shaft, mutuyok mo to one because unsa may gamit ana. If you want to drive the gear, the pulley or the sprocket or the hub. So we can understand this, no? This drawing. The hub is outside, pulley ba or gear, and then you insert it on the shaft, and then you insert a key. So that when your shaft will turn, then of course, madala tong imong hub or pulley ba siya or sprocket or gear. Okay? Now, from table, by the way, our study will just, there are different types of keys, no? I'm going to share to you, sa different types of keys. Gamay kayo nga drawing. Different types of keys, I'm going to share to you. The different types of keys. Can you say it, class?
Yes, sir.
Okay, you have the most common, which we are going to study, is the square key and also the flat key. It could also be a rectangular, no? Not square, but it could also be a rectangular key. But the most common is a square key, and then you have a flat, then a round Kennedy, then you also use a tapered pin, and then a give head key, and then involute splines. These are all different kinds of keys. But the most common that we will study, that we will only discuss, is the square key. Mag-monetize. Mag-monetize. Asa man ako ito? Yeah, man. Okay, so those are the different kinds of keys. The common is the square key, which is we are going to discuss. Next is there is a table for the dimension of keys, because probably if we are going to just insert any key, probably the key is just too large or too small. So there is a table. There is a table in table 3-2. Okay? 3-2, where the key size is given correspondingly to the shaft diameter. And you will notice it is in English system inches from a shaft diameter of the first, from a shaft diameter of 1.5 to 9/16, your key is 1/8. All of these are in inches, no? So if you have a shaft of 2 inches, what would be the dimension of the key? If it is 2 inches, what would be the dimension of the key if your shaft is 2 inches? 1/2. Okay, do you see it? The range of 1 3/16 to 2 1/4 belongs, no? 2 inches belongs to that. And your size of the key is 1/2. So if it is 3 inches, diameter of 3 inches, you should have a 3/4 key. Do you follow, class? So as your shaft diameter enlarges or becomes bigger, correspondingly your key also. These are standard dimensions, no, of keys, or recommended sizes of keys. Okay, any question? Class, any question? Wala ra? Do you see our discussion? Class, do you see our discussion on the table 3-2?
Yes, sir.
Okay, so I'll stop sharing. I'll go back to our lecture. Okay, so this is your key, and let us say this is your shaft. If the rotation of the shaft is in that direction, no, clockwise, then you will notice that this side of the shaft is pushing the key in that direction. And it is also, the key also has a reaction in the surface. And this side is the side that is holding the hub. And this is also the side on the key that is in contact with the hub, that is pushing the hub. Do you follow? Huh? So your shaft is rotating in that direction. This is the side wherein there is a pushing between the surface of the shaft and the surface of the key. And this is the side also where there is a pushing of the surface of the key to the surface of the hub. So kani dire napital luag ni siya. No, wala ni siya ikuan. However, in certain cases mo-action ni siya og lubag, no? But with this condition, assuming no na kuan, this is the side wherein there is a force of contact between the surfaces of the key and the shaft, and this is the side wherein the surfaces of the key and the hub are in contact or pushing against each other. So if we draw it in 3-dimensional, you will notice that this is on this one, no? Do you understand my drawing, or huh? This is the total force which is acting on the centroid of that. So this area here, that area, can you see what I'm pointing at? Is this one. And this area here is this one. Okay? Any question? Okay, ra? Nothing complicated? Okay. So let's go right away to an example. What you have here is a 3/7/16" diameter shaft. Is made from a material with a yield point value of 58,000 psi. That is the shaft material yield point. And then you have a 7/8. Is that correct? Let's look at again the table. The shaft is 3/7/16. The shaft is 3/7/16. And the key should be what? Okay. Let me share again. Okay, where is it? So it is 3/7/16, 3/7, from 3 3/8 to 3 3/4. Is that correct? 7/16. Is that correct? This is the range where your shaft diameter belongs. 3 3/8 to 3 3/4, and your K should be 7/8. Okay, do you follow, class? Class, do you follow? Huh?
Yes, sir.
Mingaw man. Okay, sige. Okay. 3/7/8 is almost 4. 7. Okay, let's start by counting by 16. You have 1/16, 2/16, 3/16, 4/16, 5/16, 7/16. What is 3/8? It is 12/16. 12/16 and 3/8, di ba? Okay, so it is 7/8. It's not 1. Okay, class, so let's proceed. So, again, going back to our discussion, we have a 7/8 by 7/8 key. So it's a square key. Now, the material of the key is 48. Yield point of the material of the key is 48,000 psi. And we are going to follow by maximum shear stress theory, the yield point in shear is equals to 1/2 the yield point in tension. We have discussed that, no? It is based on the Mohr circle, where for a simple tension, the value of the tensile stress when compared to the drawn in the Mohr circle, the maximum shear stress is only 1/2, because in a simple tension, this is your Mohr circle, this is your tensile, and this is your shearing. So that is the diameter, this is the radius. So this is only 1/2 of this one. We have already discussed that. Okay? So that relationship is being followed, that the yield point in shear is equals to 1/2 the yield point in tension. Now you will notice this is always the case this relationship is always used because materials are being tested by tension. No? Inato na sila, no? That is so that's why the yield point in tension is the usual test for materials. So the property of materials will be given in yield point in tension. And the factor of safety is 2. Now it did not specify whether it is for the key or for the shaft. So it holds true, no? Factor of safety for the key is 2 and factor of safety for the shaft is also 2. Wala man specify. So, and then we are going to find the length of the key based on the torque value of the gross shaft. Okay, what does this mean? Torque value of the gross shaft. So, the load here is the torque, and this torque is based on the gross shaft. So, if you try to recall what are the formulas wherein it involves torque, because first we have to get the load of this. We do not have any load. We only have materials. So we need a load. It could be a force. It could be a stress. It could be a torque. Now, what is being given here is that the torque value is based on the gross shaft. Meaning, another way of explaining that is that the shaft, what is the torque on the shaft that will give you the yield point of the shaft? In other words, atong kuan nga unsa tong kuan torque? Unsa ay formula sa na torque? Sa shaft, karong na torque. Unsa man ang formula? Shearing stress is equals to TR over J. Kuano na siya? Parente na sa MC over I. MC over I is bending or flexure stress. Torque is TR over J. Okay, TR over J. So we can get torque from here. However, we already know R and J is pi d to the 4th over 32. Ang 64 atong I. Okay? So those are things that or should be familiar already to you. Okay? Dol-dol raman, but just don't mix it, no? Ayog bayluha. So nanatay pi d to the 4th over 32 R. And then we also have a yield point for the shaft. And we also have the factor of safety. So therefore, we can get the torque based on the gross shaft. What this means here is that the shaft alone is being stressed with a given yield point or working stress, which is the yield point over the factor of safety. This is the working stress. Yield point over the factor of safety. So, the yield point for the shaft is 1/2 of the yield point in tension, which is 58 over 2, 58,000 over 2, that's 29. Now for the key, the yield point is, again, also 1/2 of the yield point of the key, which is 48,000 over 2, which is 24,000 psi. So we have 2 yield points. For the shaft, it is higher than the yield point in the key. So, we substitute values for this one. No, the yield point in shear or the factor of safety is equal to TR over J. Remember that TR over J is shearing stress due to torsion or twisting. Atong MC over I is flexure stress. And the result of that are normal stress, either compressive or tensile. Okay? So, we now have this. yield point over the factor of safety is equals to T. R is the diameter divided by 2. And pi d to the fourth over 32. I use d, pi d to the fourth over 32. R here should be the outermost, the maximum shearing stress that the shaft can take. And it is on the outermost surface. Kaya ang R na is the radius man. If you go inside, your R there will be smaller. So your stress there will also be smaller. So your R here is the radius from the center to the surface of the shaft. Okay, so we can solve for T. No? Apply your algebra, you can solve for T at 115,644.77 inch-pound. So, if you will notice here, we are not using torque, but we are using force on the K and the, no, because what we are analyzing is the K and the shaft. And the stresses involved are force over area. No? This is compressive. No, these are compressive stresses because this side is pushing, no, this side is pushing, this side of the shaft is pushing that side of the K, pushing, no? Now, this kind of stress, there is another term for that, no? Because when we talk about pushing against each other, we could, if you try to recall, it is compressive. But actually, there is another term for that, similar, but it is, the definition is different. Because compressive stress is, if you have a material, compressive stress is you analyze it somewhere here inside. That is compressive stress. Now, within the material. However, when it is on the surface, that is called bearing stress. No? So like your shoe against the floor, no? There is bearing stress between the two. No? Surfaces na siya, kanang bearing stress, but its definition is very similar to compressive stress. This is more familiar with the civil engineers. Kay kanang ilang mga footing gani sa ilang building, those are bearing stress. So, bearing stress na siya kanang mga building nila nga that will kanang the columns and then there's a footing and then it is pushing the soil, that is bearing stress. Okay, so that is a new term, bearing stress, because you might be surprised why there is a bearing stress here. So from here, if we know the torque, we're not interested of the torque, but the force acting on the surfaces. So, in this solution, it is being simplified. There is a simplification because the force acting on these components of our analysis is not on the middle, but it's actually on the surface. Why? Because force is equals to torque over radius. So actually, nasa there. The force is actually there. That is a simplification of this solution. No? So the force is actually here. But it is being simplified. If you follow your PDF file, that is force is equals to torque over radius because torque is force times radius. So if you substitute the torque and also the radius, you will get a force of 67,284.23. So far. Okay na? Okay, so let's start our analysis. We already have a force acting on the surface of the shaft that is pushing the key. From the shaft, pushing the key. Or pressing on the key. So the first is based on the bearing of the key. Okay, based on the bearing of the key. We are going to analyze based on the bearing of the key. So let's go back. This is the key and it is being pushed by the surface of the shaft here. So it is this one. So we have force. What is the area? What is the area? Okay, bearing area. We are given that this is a 7/8 by 7/8. So what should be the area? No, just tell me how much is it? Because this is 7/8 by 7/8. The area should be 7/8 by 7/8. And it is this area here that is the bearing area. So what is the area? Based from this, just one. Do not give me a calculated value. Based from this is 7/8. It should be what? 7. Again? 7/8 is this one. The dimension of the key is 7/8 by 7/8. So this area should be what? 7/8 divided by 2. It is 7/16. So this is 7/8 divided by 2, 7/16 times length. Okay? So that is the area for the bearing of the key. Any question? Any question, class? Wala question? So let's go back. So based on the bearing of the key, it is yield point over the factor of safety is equals to the force over the stress area, where stress area is the bearing of the key. The stress area of the bearing of the key, which is 7/16 times L. Our yield point is for the shaft. By the way, we are talking here of the, sorry. Ang first is shaft, I'm talking of the key, but actually it is the same surface on the shaft. No, it is this one, that is the surface of the key being pushed by the same amount of surface from the shaft. Kini siya, kini. This is on the key side, this is also on the shaft side. So both the same area is on the key side, and the surface that is pushing that is also the same area on the shaft side. Okay, so based on the bearing of the shaft, so our area is still 7/16. Our yield point of the shaft is 58,000. Factor of safety is 2, and then our force is, as we have computed, it is 7/8, no? 67,284.23 pounds. Okay? So we can now compute for the length of the key, required length of the key, based on the acting stress and stress areas. So the length of the key is 5 and 5.3031905 inch. Now, how about bearing of the key? Let's go back. The bearing of the key is, the stress area would still be the same. Okay, because this is the two areas that are pushing against each other. So the area is still 716 by L. Okay? So, based on the bearing of the key, yield point now of the key. The first one is shaft. So this now is on the key. So yield point of the key over 2, force over stress area of the key. Again, the same stress area as the shaft. 716L, and then our force here is 67 to 84.23. So our length of the key is 6.408022. Based on our computation of the length, based on the bearing of the key. Next is the shearing of the shaft. Go back. Shearing of the shaft. Actually, there are only two parts here: the shaft and the key. The hub is not being mentioned. If it has been mentioned, probably we'll also analyze the bearing of the hub. Pero wala man dere, it's only the key and the shaft. So the question here is, what is the stress area? Shearing stress of the hub, of the key. Which is now this one, no? This area, which is 78L. So the shearing stress of the key is 78L. Okay. So, based on the shearing of the key, yield point of the key over factor of safety, force over stress area of the key. And it is 78L. Our yield point of the key is 24,000. Factor of safety of 2. And then our force is 67,284.23. And we will get a length of 6.408022 inch. So we have actually computed different lengths of key for the same different analysis of stresses. So if you base it on the bearing of the shaft, it will require this much, 5.3031905 inch. If you base it on the bearing of the key, it will also require a length of 6.408022 inch. And if you base it on the shearing of the key, it will be 6.408022. The question is, what should be your final length of the key? Which one? It should be what? Why should it be 6.4? So what's the reason? What's the reason why we chose the larger one? Unsa to? What should be the reason why we chose the larger one? You chose this, no? 6.408022 inch. Why did we choose the larger or the longer one? So, madako, unsa to? Now, when you talk about cross-sectional areas, these are relative to what analysis, whether it is shearing, bearing, ana. But it does not justify why you use this bigger value. Safety, why? Oh, so if what, for example, if I'll say for reason of economy, oh, I'm going to use this because it is shorter. Why will not this be safe? Okay, so if we are going to use this, it will be this will fail, no? Because it requires, if you use this, for example, the length is this one, what will happen is this one will be now, our factor of safety will now be less than 2. Or if you make this smaller, what will happen is this value will become bigger. And this value will become bigger, meaning your working stress is bigger than this one. This is your working stress. So if it will make this bigger, it will make this bigger, kaya equal na sila. And your yield point is 48. What will happen to your factor of safety? To make this bigger, so it becomes smaller. So that is the, or another way of saying it is, if you use this, you don't have to worry about this because the factor of safety will be greater than 2. But if you use this one, the factor of safety here will be less than 2. No? Because what will happen here is, if you use this one will be smaller, and it will make this whole value bigger, and it will, if you look at the factor of safety, if this increases, then it is understood that your denominator decreases, so to make it increase. Okay, so that should be our conclusion, that the length of the key is the bigger length. Now, stress concentration factors are also given in shaft with kiwis in table 3-3, page 165. If you are interested of incorporating the stress concentration factors because of kiwis. Okay, any question? Lara? Okay, so you
Yes.
take your, yes.
Kanang sa bearing ug sa share pagbulong sa lens, sir. Sige na magkaparehag answer, sir. Or depende sa given as problem.
This is based on the sharing of the, this is for the key, and it depends on whether your key is square or rectangular. Because if it is rectangular, then dili naman parehas ang stress area. Dili na kuan, no? Did I answer your question?
Yes, sir. Yes, sir.
What will happen is, this is always 1/2 of this one, if it is a square key. What happens if it's a rectangular? Probably this is a little bit longer. So it's not anymore 1/2 of this one. This one is, that one is not anymore 1/2 of this. Did I answer your question?
Yes, sir. Gets me, sir.
Okay, so you take your screenshot for the keys. You can also take pictures now. Okay na? I'll transfer to the other board. Class? Okay na class?
Yes, sir. Talaga, sir.
Another also important thing here that you have to take note is that, okay na? Humanitag screenshot? Are you done with your screenshot?
Yes, sir. Pa-screenshot ko kay Casbert, sir. Thank you, sir.
Another thing that you also have to look at this values here is that in our solution, in our conclusion, it is the length of the key is based on bearing or shearing of the key. Huh? It is either based on the shearing or the bearing of the key, not on the shaft. Why? Because of their yield point stress. You will notice this is the same as this one. But what makes it different is this. Their yield point. Meaning, your shaft has a higher yield point than your key. So, meaning, your shaft is stronger than your key. In other words, if the load on the shaft between the shaft and the key will exceed or will be large, which of the components will give way? Okay, it should be the which of the components will give way? Asay unang madaot. If for example na overload nimo imong kuan shaft and key, ang force nga being carried by the shaft and the key exceeds, which one will fail? It is the key. And is that a logical decision? To have the key to fail first. Okay, that is a very common practice in mechanical engineering. Why? Because it is easier to replace a key than replacing a shaft. The key is like a fuse. Mura na siyang fuse. Nga, in cases there is overload, ang fuse mo give way. Dili ang imong alambre, no? In electrical terms, no? Naka-alambre, and then what's the purpose of the fuse? In case of short circuit, dili maputol imong alambre. Ang fuse mo maputol. That is also the same function for a key. In case of overload of the shaft and the key should fail first because you will be replacing the key and it is a very small portion, no? Rather than replacing the shaft. Okay, any more question? Wala na? Okay, kung mawala na, then that will be all for today. And then I'm going to ask you again to turn on your cameras, please. Turn on your cameras. Please turn on your cameras. Oh. Okay, class. Are you still there?
Yes, sir.
Okay.
Yes, sir.
So reminder for our exam. Reminder for our exam this Wednesday, no? We will be using our book, blue book, no? We are using our blue book, and then we will be having it on the conference room, which is the third floor, on the third floor of our building. And then you bring with you your calculator. I will not allow borrowing of calculators from your seatmates. And then, of course, I also do not allow use of cell phones. Okay, and then, what else? We will follow our schedule. No? We will follow our schedule because ang uban na ay klase of 3 o'clock. Okay? Anything else that you want to ask about our exam?
Excuse me, sir.
Sa
Ito
to?
yung coverage sa exam, sir.
Coverage. Nangutan na po coverage. Tebsa, starting from the beginning until the Moore circle. Absent ka, sige na kung balik-balik ka na.
Thank you, sir.
Not necessarily. I would say it is safe, no? Aron in case probably isa pwede naman gud og isa og mayo gud mo bahig ang inyong solusyon. Ha? So you just to be safe, you have three booklets, blue books, no? Any question? What's that? Oh. Yeah. By the way, I do not accept kanang pencil. No? Eh basig akong irison. No? Ilisan ako akong irison. Butangan akong sayop ba? Ang insakto. Butangan akong sayop. Actually, so I do not allow using of, but do not use red ball pen, ha, because that is reserved for the checking. You can box it, or you don't need to box it, because I will go through your solution.
Sir, pila ka ba problem sa exam, sir?
Okay, I will choose the wrong one. Huh?
Excuse me, sir.
7 rin yapon. By the way, we use 7 significant figures at decimal place significant figures. Because if there is no decimal place, for example, it is 1 million, ana, ya wala na Tanan. Because the importance of the 7 significant figures is so that you will carry the accuracy. Kaya og madili din for example, to significant figures ra. They ang 25,265, 25,000 ra na. Nilapaw na na. At least man ako ingon. So at least 7. Oh. 8 na siya, round off. May mo na siya 8.
Sa formula sa technique sir, may XC equalizer, ang moment sir, significant sir, ang naka-8,
It doesn't matter, mas mayong, mas daghan. Oh. I just require at least. Pero, aron din na mo maguna-una o round off, isulat na lang tanan. Oh. So that you will not be thinking of how much is this rounded off. So, do I add 1 or does it retain? Di ba? Ano man na siya? The rule of rounding off in the last digit is either you add it by 1 or you retain it. No? So, if you, aron di na ka maguna-una, unsay makita nimo sa, I think calculators have at least 10? 10 man na siya. Ugma. I-convert into kuan. Shear stress.
Unsa man ang di ba sa formula sa transfer A equals B area over 90.
Shear. It depends on where I am specifying the location. I'm going to specify the location. If for example a beam, it has to be specified where is the transverse shear stress.
Sir, sira na to PDF ko sir ba? Abi sir, sir download sir. Napakita na sir ang pattern sir kanina transfer sir.
Wala gibutang og asa. It's not being specified.
Ano siya maximum?
No. What did it say? Maximum transverse shear stress? What's the problem?
Abi sir, find ang sir ba transverse
Shear stress where? Any part of the beam, it should be specified. If it is maximum, then you find the maximum shear.
Sabi maximum sir, asa dra maximum shear stress ana sir? Kani sir, kani 2,000 sir.
Kani, ilan eh?
2,000.
Oh, so that's correct. Any of these two. If I say maximum transverse shear stress, but if I say transverse shear stress at 3 inches from the end, oh, you have to find the transverse shear stress. Oh, where is the location of where you want to find the transverse shear stress? Oh, so you look at it, you determine what is the transverse shear stress at 5 meters. You do not know. You have drawn it there. Kana imong drawing, wala ka kabaloon sa ikuan. Pila ang imong transverse shear stress sa 5. Naman ni imong. Oh.
Dali ra na siya sir, dali. Mani siya transverse stress ako. Ang maximum transverse.
Maximum transverse shear stress occurs at the location of the beam where there is maximum shear.
sir, mo siya maximum.
Oh, di na, diha. Ug moingon ko nga, for example, 1 meter from the end, di ato kas asa dapitan ng 1 meter from the end.
Ano ko nakita sa internet sir nga iya pang ang kanito 1,000 sir, di minus pa ni Ari sir, pali na sa yang resultant sir no. Ito ba na sir? Okay sir, nakita na kana ko mag-iya pa mag-minus ning kaning R3 ba? Yang R3 sa on shear stress.
Dili, V kanay mo ni V gyud. Ang V mo ikuha na. Ang V mo ikuha na. Any question, class? Isa pa to, napat question?
Question, sir.
Oh, isa man.
Mga around pila ka problems ang sa exam, sir?
3. But actually, it involves 4, no? 4 topics. So, 3 ra ka questions.
Thank you, sir.
Tao na ba ni sir? Moment of inertia sir, dapat anak sir. Dari mo si Jesus center of gravity sir. So dari sir, only ang mo Y1 Y1
Depende, ay mo reference dire. Pwede mo kay reference ito sa taas. Kana siya, o kana o kana. Dili, are you sure it is center? Lahi na siya, pero kana siya minus kana mo man na. For example, nakakuha ka kuan center of gravity. Aun sa mo?
Abi sir kaning sibra na siya sir. Di ba sir ang formula sa Barrington Theory A1 man sir sa ana equals A1 Y1
Oh.
A2 Y2 Y1.
Oh.
Na kaning kuan sir kaning Y1 P3 at Y1 sir. Una Y1
kana Y1, kini Y2.
Y2 3. Kasi sibra na siya sir. Abi what 3 ang Y1 sir, ang Y1 yang Y2 kay kani.
Kana oh. Ang magawas ana is this one kini na imo nakuha gani ha. Oh, asa na to na naka center of gravity. Probably na imo center of gravity dire. Dili gyud siya maparehas kay ang imo center of gravity base sa taas mubo man siya.
So ang sa answer naman sir. Kanina lang.
Walay kaso. It doesn't matter whether your basis is on the below or on top. Dili.
Indicate ra kasi siya mo indicate ra kasi
From the top or from the bottom. Bending stress mo gyapon na siya. Even whatever.
Kailan lang ka mag-compare ka mas sa mga pinaimo.
Unsay lahi? Dili makuan. Unsay pasabot nimo lahi?
Di ba sir, formula ni sa alam na sir sa EF bending max is equals to MC over MC top.
Oh.
MC top over I.
Max na siya?
Oh, max.
Nganong kabalo man ka nga maximum diri sa taas?
I didn't order sir MC one sir MD kaning top sir ba?
Top on. Moment. Then C sa top from the neutral axis towards the top. Over I.
Kailan lagi sir ang answer sir basta unahon ni sa sir mo yang
Dahil siya basta
From the
Dili man.
Depende man mo di from center wala yun sa the top or from the bottom.
sir ana lang sir basta ang problema na sir nga wala na ang sa answer.
Dili gid na siya lahi. If this is your, let us say, center of gravity,
sige. Neutral
on
axis.
your axis, dayon, of course, the bending here is not the same as the bending here. Because you do have different shape. Pero, whether your solution is, kabalo naman ka, pila ang C ane, or pila ang C ane, it is the same. It should be the same, huh? Oh. So, it depends on whether mayon nga maximum bending stress. So, ang C nga maximum mo na imong pangitaon. Which is longer C, this one or this one? Oh, di maximum man ka. It did not.
Ang longer gray pangitaon sir ang longer.
Mangita man ko. For example, imong answer kanay mubo o kaning taas. Katong mubo may akong chikan. Okay, is ini yung mga maximum, di ba? M C over I. Asa may makakuha kag maximum ang C? Kanang taas nga C. O, nya nga nun, pilion man mo itong mubo. Class, are you still there?
Yes, sir.
Yes, sir.
Did you hear
Yes, sir.
our discussion?
Yes, sir.
Okay. They're talking about the maximum bending stress. You should use the C which will give you a maximum. So C on the outermost fiber which has a longer outermost fiber. Hey, good, yeah, of course. So there are three problems, but it's already incorporated in the flexor and one. Oh, so your exam will be three problems, then but it involves the four, no? Katong flexure or bending, transverse shear stress, then katong superposition, or more circle. Oh, there are four topics, but only three problems, no? Because the first problem I involved it the flexure and the bending of flexure stress and the transverse shear stress. Okay, so just make sure na. So for the first problem, it involves the transverse shear stress and the bending of flexure stress, and then the loading has a distributed load, no? It has a distributed load. Anong distributed ba? Para sa itong iyang gikuan, that is a distributed load. Mano man? It has a distributed load. Ato, distributed man to. Anak man. Kanang kuan, let us say, anak, nga loading. Distributed man na siya. Pwede ra po, taman ra diha, anak.
Yung amlo na sir, ana.
O kani siya, anak na siya. Anak.
Yeah, uniform na dyan siya sir or
Oh, I will not complicate it with you a triangular. Dili na ko mo kuan ng triangular kanara. Uniform lagi siya. Dili triangular. Uniform dili katong triangular ba? Oh, three problems. And then the superposition, for the superposition, you have to find the maximum stress. Remember the distribution of the superposition is na si ana og na mana og ana, diba? And finally, it should have something like probably this one, no, ana. So which is the maximum stress? Ay, oh.
Sir, pakita kami, sir.
Oh, itabunan nila. Kita na mo?
Okay na, sir, kita kayo.
Oh. This is for the superposition. Atong naay kuandere, it involves this one, and the final looks like this. Diba, nairog siya? So you're going to find the maximum stress on that. So of course, the longer one, atong kuan will be the maximum.
yung kato sa uniform load sir sir.
Atong kuan, atong flexure o atong kuan. And then of course, I will also ask you to locate the zero. Kaning zero asa dapit na siya. Locate the zero stress. Okay na yun. You can have it either from the left end or from the right end. Bahala na.
Yes, sir. What if, sir, that's what I'm saying. Bukan sa growth. Locate the zero, or sa putaran ng arrow.
Oh, whatever. Oh. Or point ka from the left edge, from the right edge. Or nasa inyong drawing. If you indicate in your drawing, akong i-follow. Some more circle, I will give you coordinates of a certain element, and then it is tilted from the x and y axis. Pero dili na ko ihatag ang element. Just worded ba? Okay. The element has the following stresses, which is certain degree. Element, I'm talking of the element, not the Moore circle. Kaya madouble pa na siya sa Moore circle. The element has following stresses, which is how many degrees oriented from the x and y axis. Yeah. Muna dayon, find the other stresses. The Moore circle, you have to draw it.
Yes, sir, na plus points and drawing, ano, sir?
Oh, the element should be drawn. It is, ang element should be drawn, no? Including the angles, ha? Including the angles, because dili man pwede nga, ana rata na inyong element, or sa x and y. You have to indicate the angle.
Kailangan ba accurate ang angle?
You just approximate. You just approximate. Ha?
Sir, apel to may graph. Ay, wala.
Hindi na ako kadumdum.
Sige, graph. Ito ngayon, mura ka lang.
Wala pa ako, wala man ako. Wala, pati na ko
Darasyo.
Wala pa. Wala pa na ako tumakuan. I have not decided on that.
Sa last one, ito sir, last before naman sir, after naman sir, before naman.
Last year, sir, ikaw magyapag ito na sa machine design.
Ha?
Asa sila na masayong sir? Ito last year na mga machine design sir.
Asa na?
Asa sila galistod ng topic? Dagan sila.
Di na ako kadumdum.
Sir, pero ikaw may machine design last year.
Oh.
Nakagapong sir.
Ha?
Nakagapong.
Ang problema last year is akuan sila online. So daghang kayo parehas og answer. Daghang po parehas og sayop. Wala naman malang-alang mangkuan ko og kinsay original ani.
Kasi mahal na sila sa mga kaya.
So that's why for the College of Engineering we really want an face-to-face exam. Dili kayo masaligan ng online.
Buta no minsan. Masaligan no.
Oh, come diha online. Any question?
Yeah, siya control access kita na niya yan. Sige na siya mausap.
Maxi.
Utang na kanya.
Hindi ko tramagod ng giingon, sir. Katong bigger na siya.
Kanang sa neutral access dia, di na siya mawala.
Depende.
Hindi ko ganun pangitaan. Asa ang neutral?
Sa tuna
Pwede siya naminaw nila sir.
Naminaw ko.
Sir, oh.
Naminaw ko sa environment. Sakto din.
Oh, nismile siya.
Ganda lang ito nga sa mga sagot tungkol sa.
Depende. Muna mo lang.
Ha?
Kupaton.
Unsa may mga libro nila gamit karaan man to ka.
Kamera mo, sir. Yan, dapat ba?
Amo nakita mo libro ko gatong.
Nakabasa na ako power plan sir.
Unsa?
Nakabasa na ako power plan sir.
Estudyante pa ko, di na ako kadumdum og unsa to among kuan.
Sir, wala na. Sir, niya na lang ako mag-klase.
Mag, dili. Mo. Lain to amo, murag ito to.
Study naman sir niya. Bracket ko sir, magbalik sa pressure. Madili siya mag-change ba? Dili ka yung nanin mong stay na sir. Belt ready po lang.
Unsa man na siya ka?
Change, sir.
Anak niya sir. Kung siya clockwise, ulit yung clockwise. Dili, dinami kung siya counterclockwise no. Chain recoil, belt recoil yan sir.
Pwede mo siya paano kasi. Pwede lang.
Unsa to?
Pwede. Amo atang i-concert mga kaning last nga gears sila sir gears. Ayun kani siya mo inaasa na kanang pedal. Kani nga na pedal. So pag tuyo kani niya sir, padulong dito. So kani siya padulong pa dire ang mount sir nga kaning isang gear dire patras dire ang tuyo pa.
Ano naman sir?
Gamit ni kunani nga belt mo ano talaga sa belt mo pwede gamitin.
Wala na siya roy ko ang flat belt ra may pwede ana god. Chain dili pod. Ang lain ana is yo kaban idler. Idler in between. Oh. Then, clear na siya. Kung iyo man ang itaod diretso, ana man din ang tuyok no. Pero butangan na imong laing gear diha, kani siya motuyok ana. So, kani siya motuyok ana.
Butang di kong gearbox sir.
Idler ba? Idler. Mato nga, tanawa. Kaya originally, ana natuyok. Ganani yung pabali.
Dili sir, ang tuyo sir kay paana sir. Among
Lagi.
paana na mo dire amo ipaana dire kani siya sir sakto na ni siya nga tuyo.
Dito ra, oh.
Oh, ganahan mo nga. Ang kaya ang tuyo kung sa originally sir kay kadulong dito. Paana sir ba ang original nga tuyo kay amo ipa-atras ng tuyo sir.
Mo lagi. So, mo na ni. Kanina between kini.
Oh.
So, og gaana na siya og gaana, kay nanay ang tuyok. Asang ganahan yung tuyok?
Ayun dire sir, amo ganahan tuyo.
Ay, dire. Diretso ra na yung tapot. Tuyok naman na sila. Dili ra, diretso ra ninyo ano.
Kadulong na dire atras tayo ba.
Oh, kay ana o gana man na. Gear man kani.
Pero wala siya connect sir.
Kasi ito na i-build mo na sir ba? Buta na ako chain sir. Ano siya? Sige na siya. Chain build.
Di mo ka kuan. Og nasa yung sadya?
Wala na siya i-call mo sir. Wala na siya i-utang dali. Open na siya dali. I-connect na siya. Chain.
Mobile man.
Tuyo ka niya sir. Tuyo ka niya. Kaya padulong ako dito.
Oh.
Kaya chain man. Ako mga mabalik. Kaya tuyo ko.
Belt recall.
Dili, ang problema sa belt katong flat belt wala naman na ron. Di belt magod ang kuan gamit. Flat belt iana ra man ini mo ilubag ra. Ilubag. Di ang kuan dili.
Gearbox, one station gearbox.
Ano mo rin kay ano siya. Kung may tara ni biglang ni sir.
Mandarin front sir. Bracket sa bike. Gears. Ikaw na change the whole sir.
Tignan ko sa gears din ang katapat.
Ngano kinahanglan mo agi gyud sa dire.
Okay, wala na sir, asin kayong change niya. Ano ba ang
Ipakita ko yung model ba?
Og kuan rat. Og idiretso ninyo dili ni ko mo makadiretso.
Dili sir kay amo mo kitang iagi ang murag kuan sir. I was wala mo design sir guys. Nasa work. Namo ko say bike dire sir. Pedal ako. Then diri ko tong gear. Then balikan ni siya mo ni siya kuan. Ang katong sa pressure. So connect dire sir para ang tuyo ko.
So kani ga kadina mo ani.
Oh, kani mo like nadiri ang pedal, bike ni siya diri na bang nadiri ang pedal. Like nadiri ang isang gear. So kadina na sir, like nadiri tong like sedlanan sa stress siya. Like paano ang tanawon sir.
Yeah, important yun ang kuan direction nga mo balik.
Kamu butang basta sprocket sir. Kamu butang different sprocket sir. Hindi mo kinahanglan baliktad na direction ba para.
Ogma, kini din inyong balihon.
Ano sir?
Kani. Dito speakers magatubang.
Ay dito kay
Ato bang
Kana siya ang bangangan niya dito na speakers.
tuyo ni sa mulod diyan.
Dili na kay unsa may ang tuyok ani.
Baliw ni sir na maggawas kung registration ni sir ba. Gawas sa
Dito.
Ngayon diri mo
Ana siya. Kung may diretso ninyo, insakto unta.
dito job kung clockwise na Pasulod na naman siya, din na siya mag-gawas dito na dito sa
Pwede ro ang budsig ako ay gitan ko napataman ako ng posisyon ko na. Agar mo gano yung
ano problema naman. Okay, mag-gears ni sir.
Dire.
Buta na gears ay mo
Dira.
gearbox direct.
Dire ang ani mo tuyok. Dire. Gikan diha paingon. Kani unsay tuyok ani anak man no anak. Kani po siya anak po unta.
Yung ganun yung paingon direct sa
So kanan ninyo og gikan dire paingon sa duol. Dire. Then gear mo gikan diha pa diha.
gear na.
Oh. Or pwede po ani mo dire mag-gear.
Thank you, sir.
wala na concert yung murag laing tas yung ipagawa ng concert aside namin. Kasi na kayo mga first sir. Design sa ato sir.
Wala naman, kanya na lang.
Kaya siya, di ba na ibang feature nga connected sa shop, sir?
Oh, wala siya kay kanang. Usually kini siya when ang imong gi-connect imong oklon ba nimo ba? Ang mga ukal. Kay og may kuan it's either integrated siya sa shaft nga di na nimo makuha.
So, dili ako mag...
Wala na siya key. Wala na siya key. Okay na, palihog ko erase. Hindi ako namin ko anon. Okay, class. Kumana ta, class. Pareho ko.
Good afternoon.
Bye-bye.